We're going to do some integration by substitution without actually going through the substitution step. What we're going to try and talk about is how to do these by just observation. This is similar to when you did the chain rule for differentiation just without going through the whole U process. These are a little harder. They take a lot of practice. I'm going to talk you through two of the main types, but we'll try a lot more in class. So we've got an integration here. What we're trying to do is we're trying to think about what it could have been that you differentiated to get this. Integration is just going the other way around. Now if you look at this, it looks a bit like a chain rule question. Imagine that if we had a bracket of x squared minus 1 to some sort of power. Well, the power here, we took 1 away from it. We times down by it, and then we took 1 away from it to get 2. So the original power must have been 3. If you do the chain rule of this in your head, we times down by the 3. Well, that gives us similar to what we wanted there. And then we times by the derivative of what's inside. The derivative is 2x, so we times by an extra 2x. So in total, we get a factor of 3 and a factor of 2x, which works out as a factor of 6x. So in fact, this thing is exactly the thing we wanted. We've got a plus c here because it's an integration. It's hard when you first see it, but whenever you've got something at the front which looks a bit like the derivative of the thing inside, this is going to be our method. Now imagine, instead of a 6 here, imagine if we didn't have quite the right thing. Imagine if we had only a factor of 3, like that. Now this thing is no longer true. If you try differentiating this thing in your head, we times down by the 3, which gives us our 3 there. We times by a 2x, the derivative of this, which would give us 6x at the beginning, which is too big. So this thing over here, we could think of it as it's 2 times too big, so we could halve it. Think of this a bit like a bodge factor. It's how much we're having to bodge the original thing to get it into this form. These take practice. Let's have a go at another one. Okay, so this one here, it looks a bit different. Now we've got a whole lot of over stuff. Now, usually, if it was like 1 over stuff, then it would integrate to log stuff, because log stuff integrates to 1 over stuff. On this one here, if we imagine dealing with log of the bottom, so I'm just going to do brackets rather than modulus, x squared plus 3. If we imagine this thing here and we try differentiating it, what we do is we times by the derivative of what was inside, which would be a factor of 2x. So this thing here, it would differentiate to, well, we times by the 2x, the derivative of what's inside, and then it would be 1 over whatever was inside the log, which would be x squared plus 3. Now this thing here, if you times it across, is 2x over x squared plus 3. It's almost the right thing. If we look up here, if this was a 2 on top, we'd be done. Or what we could do is I could times by 2 if I also put a factor of 2 on the bottom. So I've times by half, but I've also times by 2. That keeps it the same. Now this thing in here is this thing here, which we know integrates up to this. So this thing here is half times log of the bottom plus 3 plus c. Now, this seems hideously complicated when you first see it. In general, if you have the integral of a fraction where you've got some sort of function on the bottom and you've got the derivative of that function on the top, f dash of x dx, then this thing is log of the bottom function plus c. You can remember this is a general rule. It's like the derivative of this thing on the bottom cancels out with the thing on top and you're all good to go. So what you're aiming for is the derivative of the bottom to be on the top. These are hard. I'm going to do more of this in class, but this is the general idea. Now, a word here on what to do if you just can't remember any of this. You can always do a substitution. So on this one here, if we put u equals the bottom and worked it all through, we would have got to the same answer. Same on this one here. If you'd have picked u equaled the thing inside the bracket and gone through the whole process, you'd got to this answer. As you do more of those substitutions by you'll get more confident in them. I'm going to give 2 for you to have a go at, and then I'll talk you through the solutions. So, here are 2 to have a go at, 1 of each form. This is one which is a bit like one of those chain rule-y ones. This is one where we've got something with its kind of derivative on top. Pause the video, have a go, and I'll talk through the solutions. Okay, let's look at that first one. So, this thing here, what we're looking at is something along the lines of this bracket in here, 3x minus 2, we want to have 1 power greater than the power over here, because if we differentiate this, we get this. So we integrate, we're adding on to the power. Okay, well, this thing here, if we try differentiating in our head, we times down by the 5. Okay, that gives us a factor of 5 towards that. We times by the derivative of what's inside, which is an extra 3. So in total, we'd get a 15 at the beginning. We've got a 30 here. So we want to have 2 lots of this to get to the right thing. Plus C. Cool. Next one. This one over here. Well, we're looking at something along the lines of log of the bottom, x cubed plus 2. If we differentiated this, we times by an extra of, well, the derivative inside is 3x squared, which is exactly what we've got on top. So we're done. Plus C. These type of practice, have a go at a lot of them, and if you can't see it, the golden rule is pick a sensible value of u as a substitution. So the u is the inside of the bracket here, or the denominator if you've got a fraction, and work it through, and you'll get to the same answers. If you're completely unconvinced by this video, I'd urge you to have a go at physically going through the process for each of these, because you know what the answers are. Have a go yourself. Hopefully you can convince yourself of it.